Hello everyone, welcome back to my YouTube channel Code Stack with Sandeep. If you are new here, please like, subscribe and hit the bell icon to get the latest video updates. Today we are starting a Capgemini interview question and the answer series. In this series, I will explain the real interview questions one by one in a clear and the practical manner. So let's get started with the first question. My first question was how a microservices communicate with each other. So mainly we have a two communication in the microservices, how they communicate. First is synchronous communication and the second one is a asynchronous communication. In synchronous communication, the one microservices has to wait for some fair amount of time for the response. But in case of the asynchronous communication, there is no waiting time. The parallel request is being sent and get in the microservices. So in the synchronous communication, as you can see over the screen, in the synchronous communication, one microservices directly calls the another microservices and wait for some response. The client wait until the services responds and mostly uses the REST and the HTTP request. Simple, it is quite simple to implement because it can be used where the traffic is low, there is no much traffic on the microservices architecture. It provides a tight coupling means if one microservices is down, then the request fails in order to get the response. The common technologies that nowadays we can use is the REST API by using HTTP, OpenFin, and the REST template and the web client. So the OpenFin is mostly used in the latest Spring Boot applications that provides a very smooth communication with the microservices. So here you can see, let's suppose we have one order services and the payment services. If we are placing any order over any websites like the Flipkart or the Amazon, so what we see, if any order is placed and we are waiting for the payment to respond. If order services wait for the payment services, failure in the payment services affects our order services. If the payment gets failed, you will not be able to place the order. So this is how the synchronous communication takes place. We are the client, we are filling the form and sending that to the API gateway in order to make the payment. What API gateway does, it is a single entry point of any request that is coming from the client. Here we can do the routing, that where the request has to go with the in the form of HTTP. So the request is being redirected to the order services by filtering their authentication, authorization is being done at the API gateway itself. An API gateway redirects that request to the order services via HTTP request, and the payment get successful, and then the response in the return you will get the response to via API gateway to the client. So this is how the synchronous communication takes place in the microservice. And the second one is asynchronous communication. Asynchronous communication do not wait for the immediate response. They are parallel in the nature, means one request is coming, going and coming. This is how the request and the response works. For asynchronous communication, we use Kafka and the RabbitMQ. In my microservices series, I will be teaching you the Kafka and the RabbitMQ. That is the most efficient and the mostly used message broker tools in the real companies. So they are mostly using the Kafka, either Kafka or the RabbitMQ. So we will explaining both the Kafka and the RabbitMQ. It is a message is sent to a broker is Kafka and RabbitMQ. This is basically channelize the message, how our message will be, how our message will be sent and wherever it has to go. The services communicate via the events. Loose coupling is there, means loose coupling means one microservice is down, then it will not affect the request of the other microservices they are responding. High scalability and the fault tolerance. Fault tolerance means if one microservice is down, they are waiting for some fair amount of time in order to regain their position. So we can use the fault tolerance for the fallback mechanism by using the circuit breaker. We will see in the circuit breaker concept as well. This is also being asked in the interview question. So we will see this question in the next video. Of course. So you can see over here, we have the order service saying the event. There is no any waiting time. Other services consume it independently. The order services send requests to the message broker like Kafka or the RabbitMQ. They channelize their message to the payment services. Once the payment service send the request to the notification service, and after the completion of the payment, we get redirected our request and the response to the client. So this is also the another way to question when you will be using the asynchronous communication. So whenever we have a high traffic system like Amazon, Netflix, Flipkart, they all are using the asynchronous communication, because if the one services to communicate very independently, to channelize our messages in a very parallel manner, and the event driven system background processing is used fault tolerance architecture. In the fault tolerance architecture, whenever our one microservices health is down, they are not performing well. So it is the responsibility of the circuit breaker to give some fair amount of time to that microservices in order to gain their health and again to perform their work. So fault tolerant architecture came into the picture, and they have solved the number of the problems related to the microservices. So I was also asked in the interview that how you will implement the circuit breaker on the code basis, and how what is the process of implementing the circuit breaker. So we will be seeing this in the next video by using the practical approach, that how we will be configuring the circuit breaker in our microservices architecture. Okay, so thank you for watching this video, and we will meet you in the next lecture with a new topic of the part 2 of this series. Bye bye. See you.